everyone, I'm Alfian and today we are going to solve the LeetCode challenge on the challenge number 35 on the easy section called the search insert position. And for this particular challenge, given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. You must write an algorithm with O of logarithmic and runtime complexity. For the example number 1, we have the input nums array consisting of 1, 3, 5, and 6 of the data type of integers, and the target integer is 5, and the output is index 2. And why is it index 2? It's because the 5 is placed on the index number 2 and it is still inside the nums array, and nums found the target number inside the nums array. And for this example number 2, we have a nums array of 1, 3, 5, and 6, and we have the target of 2. Since the 2 is not existing anywhere inside the number array, then of course we are inserting the output index of 1. Why is it 1? Is because 2 is placed between the index number 0 and the index number 1 originally, which is the element of 3, and 2 is placed between them, so it is index 0, index 1 is 2, and the index 2 should be placed with the number of 3, and 2 takes the place of the index number 1 right here, which is 3 right here, and 3 will be shifted to the right. And for the example number 3, we have number array of 1, 3, 5, and 6, and the target is 7. Since 7 is not placed anywhere, is not found anywhere inside the number array after the 6, then of course we are going to place it after the maximum index possible of the number array. Since we have 4 elements of inside the number array, which is 0, 1, 2, and 3, then of course we are placing the index number 4 after the index 6 right here. So this is why the output is index number 4, and we don't have a hint currently. So since we are working on TypeScript to solve this code, if you want to solve it using another language, then you can go ahead. We have the function of the search insert that takes 2 parameters. Of the first one is the nums array consisting of the integer of numbers, and the second parameter, which is the target of the number integer, and the expecting output from the function of the search insert is in the form of number or the integer. So since, if you notice anything, the array is already sorted from the lowest value until the highest value. To find this, and we need an algorithm with the logarithmic runtime complexity. So I have an idea of using a binary search. A binary search is a searching algorithm that operates on a sorted monotonic search space, repeatedly dividing it into halves and to find a target value or optimal answer in the logarithmic time of the 0 logarithmic n. And the condition to apply the binary search, we need the array to be sorted from either from the lowest to highest or the highest to the lowest, and we need to access any elements of the data structure, so take the constant time. And this is the practice code of the algorithm implementation using the C language. If you look over here, we declare 2 variables called the integer low and integer high that takes the n right here, which is the length of the array, and -1. And we are using the while loop. As long as the low variable is lower or equal to the high, then we execute the middle variable, finding the middle index using the low plus the high subtracted by low and divided by 2. Since we are using the JavaScript or TypeScript, then it is possible the calculation of the high and low divided by 2, it will be resulting in a floating number, so we need to use a Math.floor. If it finds the exact target of the x right here, then of course we are returning the index. If the target is higher than the middle element, then of course we are defining the starting point or the low variable with the middle part added by 1. shifted by 1. And for the else if it's the other way around, or the x is lower than the middle element of the array, then of course we are shifting the high variable with using the middle subtracted by 1, or shifted to the left by 1. And if it's not found, then we are returning none. But I'm going to modify this a little bit. So to implement this, using the let of the low equals to 0, and for the next variable using the let high, that takes the nums of the length property minus 1. Since we are working in an array, then of course we don't want to have a out of bound index, and we can add the check if as long as the lowest value or the lowest variable is still lower or equals to the high variable. If it is, then of course we are going to declare a middle part or middle variable called the constant middle, that takes the low plus the using the Math.floor. Inside the Math.floor parameter, we can insert the I minus low and divide it by 2. And for the next one, we can add a check if target is found within the middle part. If it is, if the target is the same, strictly equals to the middle part of the numbers array, then of course we are going to return the middle part as our number of the index we return from the search insert function. If it is not, we can add a check if target is either lower or higher value than the middle part. If the target is lower than the middle part, using the nums mid, then of course we are going to move the high part, I equals the middle part minus 1 shifted by 1. We can add another check using the else check, and we can simply return the low part, which is the other way around, using the middle part plus 1. And after the while loop, we can simply return middle part. Since middle part is declared inside the while loop, then we need to declare the middle part, using the middle part outside of the while loop. Delete middle part, declare the value right here, and let's run the code. And looks like we have wrong answers. Case 1 is already correct, but case 2, the target is 2 and the expected index is 1 and the output is 0. In the case 3, we have expected value of 4, but the output is returning 3. But the case 4, we have the exact output. So to solve this, our implementation is already correct, but the one wrong or a slightly wrong approach is by returning mid instead of the low part. Oh, but we are using the low instead of the mid because the low part is already shifted using the while loop right here. From the operation, we should return the low instead of the mid part. And we have all accepted answers. How about we run this, submitting this code, and we have the runtime of 0 millisecond and the memory complexity of the 55 megabyte. So to eliminate this, let's return the middle part to be inside the while loop. Since middle part is no longer used, then we can declare it inside the while loop. So let's run the code again, and we still returning the low as our returning index. Okay, so that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.